Hello everyone, welcome to our last section of Unit 8, and we're going to wrap up our graphing stuff today, and we're going to do so by using our last term, and that's going to be horizontal asymptotes. So let's go ahead and start talking about that, and we'll talk about the test here at the end as you're looking at your first online test next week. Okay, so let's start with the difference between vertical and horizontal asymptotes. The obvious one is horizontal, one is vertical. They're still going to be denoted by horizontal and vertical dotted lines, just like the vertical asymptotes were, but obviously one of them is going to go horizontal. But the biggest difference that I want to make sure we understand is you can cross a horizontal asymptote. We make a big deal with vertical asymptotes about how you approach them, but never touch them. You should never touch a vertical asymptote, and that's still true. But horizontal asymptotes, it's possible that your graph can not only touch them, but go through them and continue on to the other side. But we'll talk about why they're important in a moment. The ways they are similar is it goes back to what we talked about with end behavior. What's happening as the graph leaves your screen? Well, as you leave the screen, you're approaching an asymptote. Same thing is true for both vertical and horizontal. So let's look at a picture that'll help clarify this a little bit. So at the bottom of the screen here, we have a picture of a graph that has two vertical and one horizontal asymptote. You can only have one horizontal asymptote. You'll never have more than one. And you'll notice the similarity I talked about. As we leave the screen, leave the screen going up, approaching the asymptote. Leave the screen going up, approaching the vertical asymptote. Going down, approaching the vertical, approaching the vertical. But you also notice pretty much every graph we've done has looked something like this as it leaves to the left and leaves to the right. It approaches an asymptote. And so that's a horizontal asymptote, something we're approaching as we leave the screen to the left and to the right. Now, we talked about the big difference being that you can cross them. So you notice in the middle, the horizontal asymptote doesn't mean much. Our middle section of the graph cruised right on through it. But as you left the screen here, we're going to approach that horizontal asymptote. And you look on the right side, we actually crossed the asymptote, and then you notice the graph curving back up towards that horizontal asymptote. So these horizontal asymptotes describe what's happening as you leave the screen to the left and the right. There can only be one of them, and you will always approach them. So let's talk about how to find a horizontal asymptote. There's three different scenarios that can occur that cause horizontal asymptotes to act differently. Scenario one here, you're going to want to make sure you have good notes on this because it's an extremely easy thing to calculate, but it's also an easy thing to get confused on because there's three different rules and there's kind of big words in the rules, but we're going to make them as simple as we can. There's a horizontal asymptote at 0. That will occur when the degree of the top is less than the degree of the bottom. So remember what degree means. Degree means the highest exponent in an algebraic statement. So when you look at these purple examples here, on the top you see 5x. Remember, that's x to the first power. On bottom you have x to the second power. So the top is degree 1. The bottom is degree 2, therefore the top is less than the bottom, your horizontal asymptote's at 0. Here, the degree of the top is 2, the degree of the bottom is 3, 2 less than 3, horizontal asymptote at 0. Over here you have no x's, you have one x, that means there's more of them on the bottom, the top is less, the horizontal asymptote, is at 0. So, really simple thing to calculate. Bottom bigger than top. Horizontal asymptote at 0. Really, really simple. Situation 2 is when the degree of the top is more than the degree of the bottom. So you look at these examples. 2 on top, 1 on bottom. Top bigger. 3 on top, 2 on bottom. Top bigger. In that case, no horizontal asymptote will exist. So therefore, you don't have to even worry about graphing a horizontal asymptote. All right, and finally, the third scenario, which should be clear, we've done top is less than bottom, top is more than bottom. What if the top and bottom are the same? That's going to be the situation where you have a horizontal asymptote located anywhere but at 0. So when the top and the bottom are the same, your asymptote is going to occur at the fraction of the leading coefficients. Now that sounds like scary big words, but here's all you have to do. 2 and 2, same. Degree is the same. Look at the numbers in front of the x squareds. 3 over 1. There's a horizontal asymptote at 3. Done, because 3 over 1 is 3. Here we look, they both have x to the first, x to the first. So you have a 1 in front and a 2 in front. So there's going to be a horizontal asymptote at 1/2. So recognizing a horizontal asymptote is all about defining the degree of the function. All right, there are also things called slant asymptotes. We're going to save those for pre-calculus, and we're only going to worry about the vertical and horizontal for this chapter. So let's go ahead and look at one example of a full graph, the most you'll be expected to do on your test next Friday. All right, so here would be our final graphing problem, the kind of largest one that I can ask you to do on the test. Everything that you know how to find. We're going to find the zeros, the holes, vertical asymptotes, horizontal asymptotes, and then we're going to sketch the graph. Realize that on the test, the sketching of the graph is a very, very small part of the grade. The ability to do the algebra is way more important. So you need to be able to do the algebra, you need to be able to list all the critical information. That's where most of your points are going to come from. All right, so to start this, I always start with the horizontal asymptotes. You'll notice the way I listed the order of things down here, I put horizontal asymptotes first because that's the thing you want to look at in its original form. So we check the degree of the function. We have a 2 on top and a 2 on bottom for the degree. The degree is the same. If the degree is the same, then the horizontal asymptote occurs at the fraction of the leading coefficient. Our horizontal asymptote is at 3. So that means I can go to my graph here and I can put in a horizontal asymptote at 3. All right, so we know what's going to happen when we leave our screen. So the horizontal asymptote's the new part today. The rest of what we're going to do should all be review. So in order to find all the other critical information, we need to go ahead and factor. Just like everything in this unit, you must be able to factor. I can take a 3 out of everything on top, making it x squared plus x minus 6. And on bottom, we have an x squared plus 3x minus 4. The numbers that multiply to negative 4 and add to 3 are positive 4 and negative 1. And we look at the top, that's not done yet. The top can be factored further to numbers that multiply to negative 6 and add to 1 are positive 3 and negative 2. So we have to be able to do our factoring in order to find all of our other critical information. We can't find our zeros, our vertical asymptotes, and our holes if we cannot find that other critical information. All right, so here we go. The zeros are going to occur when the top is going to be 0. Your zeros are going to be at x equals negative 3 and x equals 2. Vertical asymptotes are going to occur when the bottom is 0. That's going to be negative 4 and 1. Then for holes, we look here and we try to say, are there any repeated information between our zeros and our vertical asymptotes? Negative 3 is a 0, it's not an asymptote. 2 is a 0, not a vertical asymptote. So therefore, under holes, we can just put this empty set symbol saying there aren't any. There are no holes for us to concern ourselves with. All right, so now let's put all this critical information onto our graph. We can scroll down because we no longer need the original equation. The original equation isn't all of that important until we get to the drawing of the graph itself. So your zeros are at 2 and at -3. Vertical asymptotes at 1 and at -4. All right, so we have some ideas of what's going to happen here. We're going to be approaching these asymptotes as we leave the screen. We know we're probably going to be down in this lower section down here because we've got to go through this 0. And we also know that in the middle, we're going to go through a 0 as well. So let's go ahead and take a look at this on Desmos to see what we have. So I've flipped over the Desmos screen, and on Desmos, you can see what our graph looks like. And this should make sense when we go to plug this back into our graph that we've already drawn, because we have a horizontal asymptote at 3, very clear. Vertical asymptote at -4, very clear. Vertical asymptote at 1, that's very clear. So we can go ahead now and finish up the sketch of our graph by going back to our graphing screen, and you notice we have kind of a box up here to fit that graph into that we just saw. It fits into that graph nicely. For those of us that really lack artistic ability, this is really helpful because it's almost like tracing to make your graph. The work we did makes this much easier. Then we look at the middle. It came up here from the bottom, went through our 0, out the top. And finally, the bottom section, the bottom right section, we look, it came in from the bottom and out the top. So you draw that in, coming in from the bottom, making sure we go through our 0 and approach our horizontal asymptote. So this is the final piece of graphing, is using horizontal asymptotes to help us draw our graphs. All right, on Friday we have our test. We'll have a Zoom meeting next week to go through some review and make sure everyone's prepared. All right, if you have any questions, let me know.